Good afternoon everyone and welcome to my YouTube channel. So here today we are going to be solving projectile motion questions, a lot of them. So after this lesson you should have no difficulties under projectile motion. So we have a different number of questions that will equip you for an exam. Others are yet to be disclosed, like this one. So now let's begin. So now a particle is projected from the point O with a speed of 30 meters per second at an angle of 30 degrees to the horizontal. Finds the flight time. Then we have the horizontal range and also the maximum height. So firstly, when you're answering projectile motion questions, first find the x and the y component in terms of the velocity. So our vx is equal to, we are going to say velocity, then we are going to attach the cos. So the velocity in the x is v cos of theta. Our velocity is equal to 30, then we have our cos of, our angle is 30 degrees. So this will give us a value that is equivalent to, so our 30 cos of 30 will give us a value that is equivalent to a 25.98, like that. So this is our velocity in the x. Then the velocity in the y should be equal to v. It is associated with the sine of our theta. So our v is equal to 30, sine of our theta is equal to 30 degrees. Then we are going to find that the value will be equal to a 15. So this value will be equal to 15, like that. So this is our vy, like that. So therefore we are now going to solve the questions. So our ux or vx, which is the same thing, should be equal to, so now we have our ux, which is the same as the vx, the initial velocity, which is this value. Then our uy, which should be equal to a 15 meters per second, like that. So remember, so if a velocity is projected like that, we have the velocity, then it can be resolved into its components according to vectors. So we have our vx in this direction, then the one that is going up is our vy, like that. So that is how come we are able to resolve the velocity of projection into its component, where we found our vy is the one that is 15 and our vx in this direction, which is equal to a 25.98. Then our vy, which is the velocity in this direction, which is equal to a 15 meters per second, like that. So it is a vector. As you can see, this is the hypotenuse, like that. So therefore, after doing that, we can find the flight time. So to find the flight time, you can do it in two ways. The flight time will be equal to, so the flight time, you can just use the normal equation. So this is where many fail projectile motion. Which formula are you going to use? So you can be using v squared is equal to u squared plus our 2as. It is still okay. You can use your s should be equal to ut plus half at squared, like that. Then you can also use our equation, which is our v should be equal to u plus at, like that. So now what we are going to have is this. To find the flight time, let's use the equation that has got time. So let's use this equation. So we are going to say our s should be equal to u plus our at, ut plus our half at squared. So now flight time, it means to say, according to the height, the change in height, it means to say it starts at 0. It starts at 0, like this. In terms of height, it's 0. Even at the end point, the height is still 0. So we can put 0 here. So that means to say, if we consider the y, we are going to say y throughout, like that. So the s is equal to 0, should be equal to, we have the velocity in the y, we have calculated it, it's 15. Then we have our time, then we have plus half our our acceleration due to gravity is negative 9.8, because at the moment when it was thrown, we have the velocity, or we have the gravity, it is acting downwards, but the particle is more like moving up, meaning to say the gravity is opposing the motion. So we just consider the initial point. If the gravity was acting in the negative direction, then it shall be negative throughout, like that. Then we have times our time. So we have the time squared. We don't know the time squared, so we are going to have something like this. So we have a 15t, half times negative 9.8, it will be negative 4.9. Then we have t squared. So from here we are going to factorize. So 0 should be equal to t, open brackets, we have a 15 minus a 4.9t, like that. So our t value should be equal to 0, or we have a 15 minus 4.9, t should be equal to 0. Let's take this value the other side. It will be, our 15 should be equal to positive 4.9t. So we divide over our 4.9, we divide over our 4.9. So our t should be equal to, we can have our 15 divided by our 4.9. This will give us a value that is equivalent to 3.061 seconds. So this is the time, the flight time it takes. So this is one way you can answer it, or alternatively we can use this formula. The flight time should be equal to, you can just spell the word tag with a 2. So you tag someone with 2 people, so you can just think of it like this. So this will give you t should be equal to 2. Then our uy, we found it to be 15 over our 9.8. So this is the flight time. So t should be equal to 30 over a 9.8. This will give us a 30 divided by 9.8. This will give you a value of a 3.061 second. So which gives you the same answer. However, this is where many students fail. This formula is not applicable to all the situation. You only use it for symmetrical range, meaning to say you only use it when the particle is starting at this point and ending at this point, in terms of there is no change in the y. So at this point y is equal to 0, even there y is equal to 0. You cannot use this formula if, let's say, the particle is projected from this height and it falls to that height. You can never use that formula that I have given you, which is our tag. So it has got its limitation for this type of a problem. So let's look at our next question. The range of the range on the horizontal ground. So to find the range, so the range is the distance moved in the x direction, should be equal to, you are going to say u x times time, like that. So this is the formula for the range, or rather for finding the distance moved in the x-axis, so from one point to the other. So the range will be equal to, we know that ux is equal to a 25.98. we multiply by the flight time. So where this t is the flight time, it should be equal to, we have the time, which is a 3.061 second. So we are going to multiply this value by 25.98. This is going to give us a value of a rx should be equal to 79.53 meters. So this formula is applicable for any situation, whether a projectile starts from here, then it goes like that. You can use this formula, so it is applicable for any situation. Alternatively, we can say range should be equal to, we have our u squared sine of our 2 theta over our g, like that. So this formula will give rx. Now this u is the initial velocity of projection. In this case, it is equal to a 30, whatever velocity of projection you have. So we are going to say 30 squared, like that. And then we are going to have times our sine of to our theta of projection is equal to 30 degrees. Then we are going to divide over our 9.8. We are going to get 30 squared is 900 times our sine of 2 by 30. We are going to have a 60 degrees over our 9.8. So this is going to give us, when you press your 900 sine of our 60, this is going to give us a value of 779. So we are going to get 779.423 like that, then over our 9.8. So we are going to have a value equivalent to a 79.5 like that, 533 like that meters. So either you use that range or you use this formula. Now the catch is that this second formula, the range should be equal to u squared sine of 2 theta over g, can only be used if you have a projectile that starts at this point and ends at the same point. If there is a change in the situation whereby it goes below where it started in terms of the y, then you cannot use that formula. So therefore that formula has got a limitation. So that is what you need to know. So you need to know each formula and its limitation. Then to find the maximum height reached, you can do this in two ways. So the maximum height, you can use this formula, v squared is equal to u squared plus 2as, because you already know what your final velocity is. You know the initial velocity of projection. Now you ask yourself, so using our v squared is equal to u squared plus 2as, you are going to say which velocity causes a particle to move up. It is the velocity in the y, so you are going to attach y throughout like that. So to find the maximum height, you can be able to say this will be equal to, you are going to say already, if a particle is going up, the only reason why it stops going up is because its velocity is equal to 0. So we are going to say 0 squared should be equal to our initial velocity of projection in the y. We calculated it to be 15 like that. Then we have a squared. Then we are going to say plus 2. Our acceleration due to gravity is equal to negative 9.8. Then we have our s like that. So we are going to have 0. 15 squared gives us 225. Then we have minus 9.8 by 2, it will give us 19.6 s. We take the 225 here, we are going to have 225 negative should be equal to negative 19.6 s. We divide by negative 19.6, we divide by negative 19.6. Our s value should be equal to, we are going to say our 225 divided by 19.6 like that. 225 divided by 19.6, which will give us a value that is equivalent to 11.48 meters. So alternatively, so you can use hugs. So you only hug with 2 people, so just spell the word hugs. This is the direct formula for finding the maximum height. So h should be equal to, we are going to say our uy should be equal to, we know that the velocity in the y, we found it to be 15. Then we square this value over our 2. Then gravity is positive 9.8. Remember, these formulas that have been already made the subject of the formula, we just consider everything to be positive because the negative was already accounted for. So this will give you h should be equal to 15 squared is 225 over 2 by 9.8 will give you a 19.6. So when you divide this value, you are going to get still an 11.48 like that, 48 meters like that. So 225 divided by 19.6, this gives you 11.48 meters like that. So that is how you go about that one. So for finding the maximum height, this formula has no limitation. You can use it for any situation, whether it starts like that or whether it is like this. You can still use it to find the maximum height. Let's look at our next question. So our number 2 is saying a ball is thrown with a speed of 20 meters per second and hits the horizontal ground 20 meters away. Find the angle of projection. So remember, they have given us the range, which is the distance moved in the x-axis, is 20 meters. So the formula we are going to use is the range formula. Now for the range formula, we know that it's uxt, but we don't know the time. Therefore, let's use the other formula. Since this is symmetrical projection, meaning to say it starts at here, it ends there. In terms of the y, there is no gain in y. So we can use r should be equal to, you can just spell the word losing to g. So you can just spell the words losing to g, like that. So this is the way you can remember it, losing to g. So we are going to say this formula will be able to give us a value. So the range, which is the distance moved in the x, we have been told that it's 20, should be equal to the initial velocity of projection. We are told that it's 20 meters per second. So we can say 20 meters per second. We square it. Then we have the sine of 2. Our theta is equal to, we are going to have a theta we don't know, so we have theta like that. Then over our g is equal to 9.8. So we are going to do this and cross multiply. So 20 times our 9.8 should be equal to 20 squared, gives us a 400. Then we have a sine of 2 theta like that. What we are going to do is, let us multiply. So we have, okay, let's just divide. So we have 400 over 400 like that. So we can cancel 1 0. Then we are going to have 2 by 9.8. It will give us 19.6 over 40 should be equal to the sine of 2 theta like that. So what we are going to do is, we are going to send it, we are going to take the sign there. Do not divide by 2 yet. No, first take the sign there. So we have a sine inverse of 19.6 over 40 like that should be equal to 2 theta like that. So this is going to give us the sine inverse of 19.6 divided by 40 will give us a value that is equivalent to 29.34, which should be equal to 2 theta like that. We divide over 2, so our theta should be equal to, we are going to say the theta is equal to, when we divide our 2, this is going to give us a 14.67 degrees like that. So this is our angle of projection. So it is 14.67. There are 2 outcomes, 16.67, or it could be, if this is maximum range, it means to say the highest angle is 90 degrees. We can just subtract 90 minus 14 to find another possible angle of projection, which gives the same value. You just subtract the 14.67 from 90 to find the other possible angle, which will give you a 90 minus 14.67, which is, the other possible angle is 75.33 degrees. So it's either it is this angle or that angle. So in other words, when you find this, just subtract from 90. If it is the maximum range that is gotten, you can do this. So it's either it's this angle or this angle. Let's look at our next problem. So we have question 3. A golf ball is struck at an angle of theta, where theta is equal to 4 over 3 with an initial speed of 25 meters per second. Then we are told when the ball is at a height of 15 meters above the ground, the distance between the position of the ball when it is 15 meters above the ground. So our A, it wants when, meaning the time. So firstly, we know that 15 meters, it is the height. So therefore, we are going to say the formulas that we have is v squared should be equal to u squared plus 2as. Then we have our s should be equal to ut plus half our at squared. Then we have our v should be equal to u plus our at, like that. Then what we are going to do is that we are going to look at the formula that has got time. Now we know that the height is 15, so we can use this formula. Since we are also, it has the height, it has the time. This one we have v, we don't know what the v is at this height, so you shall not say this is the maximum height because we don't know. So what we are going to do is that we are going to say our s should be equal to ut plus half our at squared. Then we are going to have our everything, we are going to attach our y like that. So our displacement is equal to 15 at those 2 points. So we have a 15 should be equal to, so first let's find our initial velocity in the y and x so that we do not need to find it. So we are going to say, firstly, we have been given the tan of theta should be equal to 4/3. So we can be able to calculate the theta. So theta is equal to tan inverse of 4/3. This will give us a value that is equivalent to, so our theta should be equal to, we have the tan inverse of a 4 divided by 3. This will give us an angle of 53.13 degrees, like that. So if this is our angle, of projection, we can use this angle to calculate the velocity in the y and the velocity in the x. So what we are going to say is that we have our vy should be equal to our v sine of theta, which should be equal to the initial velocity of projection is we have, so struck with an initial speed of 25. So this was the speed, like that, so which can be resolved into the vy and the vx, like that. So this will give us a value that is equivalent to, we are going to have, so we have 25. So we can put 25 sine of the angle of projection is 53.1 degrees. So this will give us a value of 25. Then the sine of 53.1, this will give us a value that is equivalent to 19.992 seconds, meters per second. So this is our vy, like that. Then let's find our vx. So this vy is the same as your ux. So vx is equal to v cos of our theta. So our v is equal to 25. Then the cos of 53.13 degrees. So this will give us a 25 cos of 53.13 degrees will be equal to a 15, like that. So this will be a 15 as our vx. So after finding that, we can now be able to solve it. So we have a golf ball is struck at an angle of that. So we are going to say, we said that this is our sy should be equal to, you have our uyt plus our half ayt squared, like that. So our s, we said that it's 15. So the distance in the y is 15 at these 2 points. So it's 15. So we are going to say 15 should be equal to, the initial velocity in the y is equivalent to, we have a 19.992. Let's just round it off. So we have a 20 t, like that. Then we have plus half. Then it was thrown up, meaning to say the gravity at that point was acting downwards. Therefore, it shall be negative throughout. So we have negative 9.8. Then we have our time t squared, like that. So we are going to get a 15 should be equal to 20t. This by this, it will give us negative 4.9t squared, like that. We are going to take this value this side. which is going to have be positive 4.9 t squared. Then even this one, this side, it will be minus 20t. Then we have plus a 15 should be equal to 0. Quadratic, so we are going to have t should be equal to negative b plus or minus the square root of our b squared minus our 4ac over our 2a, like that. So we have our t should be equal to negative, our b is equal to negative 20. So this is our a, b, and this is our c. So plus or minus the square root of our b squared, which is a negative 20. Then we have squared minus our 4. Our a is equal to 4.9. Our c is equal to a 15, like that. So the value that we are going to get is over our 2. Our a is equal to 4.9, like that. So we are going to get a t should be equal to 20 plus or minus, negative by negative is positive. Then our square root of 20 squared gives us a 400. Then minus our 4 by 4.9 by our 15. This will give us a value that is equivalent to 294. Then we over 2 by 4.9, this will give us a 9.8. So our t should be equal to 20 plus or minus the square root of our 400 minus 294. This will give us a value of 106. Then we have over our 9.8, like that. So we are going to say our t should be equal to, we have a 20 plus or minus the root of 109 will give us a value that is equivalent to a 10.44, like that. Then this we divide by a 9.8. So it's either our t should be equal to 20 plus 10.44 over our 9.8, or our t should be equal to 20 minus 10.44 over our 9.8. So our t is equal to, when we add 20 plus 10.44, we are going to get a 30.44. So 30.44 we divide by 9.8. This is going to give us a value of a 3.11 seconds. For this other one, it's going to give us our t should be equal to our 20 minus our 10.44 is going to give us a value that is equivalent to 9.56. We divide by 9.8. So our t value for this one will be equal to, so 9.56 divided by 9.8. This is going to give us a value that is equivalent to 0.98 seconds. So now, as we can see, we have found 2 times. So the times that we have found are such that, so we have the point P, we have the point P, and we have the point Q, like that. So for the point P, what we are going to say is, let me zoom it a bit. So what we are going to say is that we have 2 times, 0.98, then we have 3.11 second. So we are going to take 0.98 second. For the first one, it's just using logic. If we have one particle, it will first have to pass at P, meaning to say the smaller time is when it passes. Then for the second one, it shall be a 3.11. So it will take 0.33 seconds to reach that point. So that is how we answer that problem. So let's now, so it takes those times. Then the distance between the positions of the ball when it is 15 meters above the ground. So they want the distance now. So we have something like this. Then we have something like that. So now what we are going to have is, we have this point, we have another point which is here. So they want the distance in terms of the x direction. That's the distance, that's the separating distance. So in other words, it's a range. So the range, remember, the range is equal to, you have our ux times our time. Now the time we have, because already if it takes 3.11 seconds here it's 0.98 seconds. So what we are going to do is that, to find the time taken to move from here up to here, we subtract the time. Yeah, it's simple logic. If this is 0 point, as long as time is not beginning at 0, it means to say you subtract the time to find how much time it will take. So this is the time taken. So time taken shall be equal to a 3.11 second minus 0.98 seconds, which will give us a value that is equivalent to, so 3.11 minus 0.98, this will give us a 2.13 seconds. So if we have the time taken, we are going to say our Rx should be equal to, we have our Ux times the time taken. So our Ux, we found it to be equal to, what value was that? So the value of our Ux is equal to 15. So we are going to put it there. So we have a 15 times the time taken, which is the difference, to be 2.13 seconds, like that. So we are going to have 15 times 2.13, which shall be equal to a 31.95, like that. So this is our Rx. So you can do this to find the distance from here up to here. If you want, you can find the range from here up to here, like that. So what you do is range, you know the x is equal to, you have your 15 times the time taken is 0.98, which will give you 15. So we can do this range 1. So from that point to that point, it will give us a 15 times the time taken for the first part, it's a 0.98. So we can do this and say 15 times 9.8. This will give us 15 times 0.98. This will give us a value of a 14.7. Then the range number 2, you know that it's equal to uxt, and for the second part we are told that it will take a 3.11. So you're going to say 15 times the 3.11 seconds, which will give you a 15 times a 3.11. This is going to give us a value of a 46.65. So this is the range 2. So now to find the separating distance, you can subtract range 2 minus range 1, which will be 46.65 minus 14 minus our 14.7. This will give us a minus 14.7, which is equal to a 31.95. So either you do that or you do that, the answer is still the same. So let's look at our next problem. Example 4 says, from the edge of the cliff 60 meters high, a stone is thrown into the air with speed 10 meters per second at an angle of 30 degrees to the horizontal. Then we are told the time of flight. Number 2, how far from the foot of the cliff it strikes the sea, and the velocity with which it strikes the sea. So here you can never use tags to find the flight time, never, because it is not starting at the same point and ending at the same point in terms of the y. So there you will just be forced to use the kinematic equations, which are your s, v squared should be equal to u squared plus your 2as, but we want the time, so we are going to use s is equal to ut plus our half at squared. So we are going to say s should be equal to ut plus half our at squared. In terms of the displacement, that means to say the distance moved from the beginning point to the ending point. In terms of the y, it is from the initial to the final point, it is just 60. Wherever it went, we don't care, but what is the difference between where it started and where it ended? It's actually 60. So we are going to put a 60 first. We are going to apply the y throughout, y like that. So firstly, let's find the velocity in the y before we can do all these calculations. So our uy uy should be equal to, we have our velocity times the sine of our theta. So the velocity is equal to, we are going to get the velocity is equal to 10 meters per second. So we are going to have 10 meters per second times the sine of the angle theta 30 degrees. So this is going to give us a value of 10 sine of 30 will give us a value of a 5. So we have a 5, so uy is equal to 5. So we are going to use this. So now be very careful. It is going up like that, meaning to say it is whatever is pushing down, it is negative. So gravity is negative, therefore even the height below the initial throwing point shall be equal to a negative 60 because it's below. So whatever is down is below. So we are going to say our negative 60 should be equal to our uy is equal to 5. Then we have our t, then we have plus our half, then gravity is negative 9.8 like that. Then we have our time squared like that. So we are required to find the time. So we have negative 60 should be equal to 5t. Half by 9.8 will give us negative 4.9. Then we have our t squared like that. We take this value the other side, it will be 4.9 t squared. We take this value this side, it will be minus a 5t. Then we have minus 60 should be equal to a 0 like that. So from here we are going now to solve using the t should be equal to negative b plus or minus the square root of our b squared minus our 4ac. Then we have over our 2a like that. So our t should be equal to, we have a negative, our b is equal to negative 5 plus or minus, we have the square root of our b squared, which is our negative 5 squared, minus our 4, our a is equal to 4.9 by our c is equal to negative 60 like that. So negative 60 like that. Then we divide over our 2, our a is equal to 4.9 like that. So our t value should be equal to, negative by negative will be equal to a positive. So t is equal to positive 5 plus or minus the root of our negative 5 squared is 25, negative 4 by 4.9. So we have 4 by 4.9 by our 60. It will be a positive value, which is a 1176 over our 9.8 like that. So we are going to have so our t should be equal to 5 plus or minus. So we have the square root of this value. It's going to give us the square root of 25 plus 1076. This is going to give us a 34.66. Then we divide over 9.8. So we are going to say t should be equal to 5 plus 34.66 over our 9.8, or we are going to have our t should be equal to 5 minus 34.66 over our 9.8. So this is going to give us a t should be equal to, we have our 5 plus 34.66, that will give us 39.66 divided by 9.8. This is going to give us a t should be equal to 4.05 like that. Then here it's going to give us a 5 minus 34.66 divided by 9.8. This is going to give us a negative 3.03 seconds. So we take the positive, time can never be negative, so we take the positive time. So it will take 4.05 to more like strike this point. So that's our flight time. So here, remember, you cannot use the word tags. So how far from the foot of the cliff it strikes the sea? So for B, how far you are going to how far they are looking at, how much did it move in the x direction. So we are going to use the range. So the range is equal to ux times time. So our velocity in the x, we found it to be equal to, we have so the velocity in the x was found to be equal to, we didn't find the velocity in the x. Okay, so we have our v cos of theta, so we can just find it. Our ux is equal to v cos of theta, which is equal to, our v is equal to 10 cos of our angle of projection, which is equal to 30 degrees. So we are going to put our 30 degrees like that. Then we are going to have our 10 cosine of 30. This will give us a value that is equivalent to 8.66 meters per second. So we can now find our range. So our range should be equal to uxt, which should be equal to we have 8.66 times the time. What is the time? The range, meaning the distance in the x. So it only hits the range until it strikes the water, meaning to say the time it will take to strike the water is the same time it will take to move in the x. So that means to say we are going to have a 4.05 seconds. So we are going to multiply 4.05 seconds, which is going to give us this value times 4.05. We are going to get a value of 35.074 meters like that. So this will be our range. So take note, this formula r for this type of a problem, r should be equal to u squared sine of 2 theta over g, can never be used unless it is just symmetrical range. It's beginning at the same point in terms of the y, ending at the same point. But if it is starting at one height going down below that height, you cannot use this formula. So that is our range there. So the next one says the velocity with which it strikes the sea. So the velocity with which it strikes the sea is made up of components. It means to say you have to account, number one, for the x component, then also for the y component like that. Then use Pythagoras to find the actual velocity with which it strikes the sea. So therefore, you are going to first find your Vy. So our Vy with which it strikes the ground, not the initial, with which it strikes the ground. So we are going to say our Vy, using V is equal to U plus our AT, we are going to attach our Y like that. So we are going to say our Vy should be equal to the initial velocity. We answered this one and said that the initial velocity in the Y is equal to a 5. So we are going to put 5 here, then we have times or plus our AT. So our acceleration, so regardless, as long as the initial, the gravity was opposing it shall be negative even if it's going down, but with respect to the origin shall be negative. So we are going to say negative 9.8 times our time. Then our time, which is the flight time, is equal to 4.05 like that. So we are going to have our 5 minus our 9.8 by 4.05 is going to give us a value that is equivalent to a 39.69. We subtract this to find our Vy. So our Vy should be equal to, we have our 5 minus 39.69. This is going to give us a value that is equivalent to 39.69 like that. This is going to give us so we subtracting 5 minus 39.69, we are going to get a negative 34.69 meters per second. So it's negative because velocity is a vector quantity, meaning to say it has got direction. When it's going down, it has to be negative like that. So this is why we are having a negative. Then the Vx at that point, using u plus our at, attaching x, we realize to say our acceleration in the x is 0, therefore it does not change, it is constant throughout. So whatever ux we found, which was our 8.66, it is this same one that is going to be there constant throughout if air resistance is ignored. So we are going to say our Vy should be equal to so our ux, which we have found, so the velocity with which it strikes the water, it shall be equal to the square root of Vx squared plus our Vy squared, which shall be equal to our Vx is found to be 8.66 throughout plus our Vy, which is changing. We have found that it strikes with negative 34.69. We square this value, then we are going to have our square root of our 8.66 squared, which is going to give us a 74.9956. Then we add plus our 34.69 squared. This is going to give us a 1203.39 like that. Then we are going to have the square root. So if we add that plus 74.9956, then we are going to have 1200. So we have the square root of 1278.3917. So the square root of this value is found to be equal to a 35.755 meters per second. So this is the velocity with which it struck the water. So let's say we have this question. It says that at a funfair, a prize award is awarded when a coin is tossed into a small dish. The dish is mounted on a shelf above the ground as shown in figure 3.1. So we have the velocity of projection is 7 meters per second like that. Then we have the range, which is the distance in the x from where the person is to where the ball is. It's 2.8. Then we have the height, which we do not know the value of, which is our height h. So the first part of the question says that calculate the horizontal and vertical components of the initial velocity of the coin. So the Vx should be equal to, we are going to say V cos of theta like that. So our V should be equal to, we have the velocity of projection is 7 meters per second. So we are going to say 7 meters. Then we have the cos of the angle of projection is equal to 60 degrees. So we have the 60 degrees there. So we are going to say 60 degrees like that. So this is our Vx. Then we also find our Vy. Vy, our velocity in the y is equal to V sine of our theta like that. So our Vy should be equal to 7 sine of 60 degrees. So we are going to find that our Vx is equal to, so our 7 cos of 60 gives us 7 cos 60 will give us a value of a 3.5. So we are going to say 3.5 meters per second. Our Vy should be equal to, we have a 7 sine of 60. This will give us a value that is equivalent to 6.062. So this is our other velocity meters per second like that. So after doing that, we are now going to, we have answered our first part. Then here it says show that the time taken for the coin to reach the dish is 0.8 seconds. So we are going to prove it. So one thing that can help us here is, in other words, they want the flight time. Now we do not know, we cannot use our sy should be equal to uyt plus our half at squared. We can use it if we had quantities, but we don't. Number one, we don't even know what our height is from this point to that point. We don't know, so we cannot use this one. So what are we going to do? So we have been given the range. The range uses the flight time, if you recall. So the range is equal to 2.8 meters. So we are going to say the range should be equal to our ux times t. Then our range is equal to 2.8 should be equal to the velocity in the x we have found is to be 3.5 times the time. We divide by 3.5, we divide by 3.5, we are going to find that the time should be equal to, we have a 2.8 divided by 3.5. This is going to give us a 0.8 seconds. Remember, you cannot find the flight time by saying 2 uy over g. This one cannot be used because it is not starting at the same point in terms of the y. So you only use this for symmetrical range. So if we did this, it cannot be able to more like work. Let's look at our next problem. It says that what is the height h? What is the height h of the shelf above the point where the coin leaves the contestant's hand? So they want the height h. So this height has to do with the y direction. So we are going to say, using our s should be equal to ut plus half our at squared. Everything we have, this is the height, so it shall be associated with y, each component with y. So we are going to have our sy, we don't know, which is our height, should be equal to the velocity in the y. We have found that it's 6.06 times the time. The time is equal to the flight time. So the flight time, it is the time it will take to reach that stop. So it will be a 0.8. Then we have plus our half. Then our a is equal to negative 9.8. It was thrown up, meaning the gravity will be acting down. Then we have times our time, which is equivalent to 0.8. Then we have a squared there. So we are going to have a 6.06. We multiply by 0.8. This is going to give us a value of 4.08 like that. Then we have minus our 4.9. When you multiply half by 9.8 times our 0.8 squared, this will give us a value of a 0.64 like that. So we are going to have a 4.08. We subtract minus. So if we multiply 0.46 by 4.9, we are going to get a value of a negative 3.136. So our sy should be equal to, we have a minus 4.08. This is going to give us a value that is equivalent to, so yeah, we have, so there's a mistake, 6.06 by our 0.8. This is going to give us a value of it's going to give us a value of a 4.848. Then when we subtract this minus 3.136, we are going to get a value that is equivalent to 1.712 like that. So this is the height that it gains in that time. So that means to say our h should be equal to 1.712 meters like that. So same approach. What is the velocity of the coin when it enters the dish? Compare with the velocity of the coin just as it leaves the contestant's hand. So we are going to say our velocity. So to find the velocity when it enters the dish, we have to find the velocity in the y. So using velocity in the y is equal to u plus our at. So our initial velocity in the y. So Vy should be equal to the velocity in the y is 6.06 like that. Then we have minus 9.8 times the flight time, which is a 0.8 like that. So we are going to have 6.06 minus our 9.8. We multiply it by 0.8. This is going to give us a value of 7.84. So when we subtract, our Vy should be equal to minus 6.06. We are going to have a negative 1.78. So it's negative, meaning it started to go down at that point before it struck the dish. Then we have our Vx is constant throughout if air resistance is ignored. So we are going to have this. Then finally, we can find the velocity should be equal to the square root, the velocity with which it hits. It's equal to the square root of Vx squared plus our Vy squared, which will be equal to the square root of our Vx is equal to, we have Vx is equal to the value of 3.5. We square this plus our negative 1.78. We square this. We are going to have a value that is equivalent to, we have 3.5 squared. It will give us a value that is equivalent to 12. We have the square root of 12.25. Then we have plus our negative 1.78 squared. This will give us a value that is equivalent to our 3.168 like that. So we are going to have the square root of our 12.25 plus our 3.1684. This is going to give us a value that is equivalent to a 15.4184. So we are going to have the square root of this value. We are going to have a 3.93 meters per second like that. So now to compare, we are going to say that the velocity has reduced. So velocity has reduced from 7 meters per second, which was the velocity of projection, to a 3.93 meters per second like that. So this is how we answer that one. So you use the velocity of projection, which was our 7, then the velocity with which it struck, it was a 3.93 meters per second like that. Let's move on to our next question. So let's solve this one. So it says that a helicopter on a flood relief mission is traveling horizontally with a speed of 30 meters per second at the altitude of 44.1 above a point P on the horizontal ground. When it releases a food package for a victim standing on the ground, the effect of air resistance can be ignored. How far from P will the package land? So we have, from here, we need to know how far it will land. Now, what I'm just going to consider is that the time it will take for it to land moving in this direction according to projectile motion is the same as if it is just going down like that. That is the law of independent motion. The x and y components are independent of each other. So the time it will take to more like just reach this point is the same time even if it was going like that, as long as it is released at the same time. So we are going to say, let's find how much time it will take for it to just be dropped down normally. So we are going to say our S should be equal to our UT. Using our S is equal to UT plus half AT squared. We have used this because we want the time. So we are going to attach our Y. Now you need to be careful. If it is moving horizontally like that, it means to say its velocity is purely in the x-axis. So it means to say it's only moving in the x-axis. Therefore, at that point when it is released, the velocity in the y is 0. So we are going to say 0 by time. Then we have plus our half. Then the gravity, imagine it is moving more like down. it means to say at the point where it is released, the gravity shall be considered to be a positive value. Then we have our t squared like that. Then we have 44.1. So it means to say we are going to have a positive 44.1. So don't get confused. When it is released, it immediately starts to go down, meaning to say the gravity is considered to be positive. So according to this, we are going to take whatever is going down, we are going to take it to be positive. That means to say even the distance below it shall be positive. If you take the gravity to be negative, it means to say even the distance below shall be a negative h. So we are going to consider the positive 44 like that. So we have 44.1 should be equal to, this is 0, half by 9.8 will give us a 4.9. Then we have a t squared. We divide over 4.9, we divide over our 4.9 like that. So we are going to say when we divide our 44.1 divide by 4.9, this will give us a value that is equivalent to a 9. So 9 should be equal to t squared. Finding the square root, time can never be negative, so we have a positive 3 should be equal to the time. So this is the time it will take for the package to be dropped from the helicopter to down. So whatever time it will take for that, it is the same as the time it will take to hit in that direction. So therefore, we are going to say now the range, we want how far. We are told that above, when it is released, when it releases a food package for a victim standing on the ground, the effects of air resistance can be ignored. How far from P will the package land? So from this point now, in this direction, it means to say we are looking at the X. So we are going to say, we know that the range is equal to our ux times our t. Now remember, this velocity was purely in the x-axis, therefore that velocity will be equal to the 30. It is not dissolved into its components like that. If you want, you can say your 30 cosine of 0 degrees, since there is no angle of projection, it will still give you a 30. And for the uy, if you say 30 cos or sine of 0 degrees, it will give you 0. So we are going to have our ux is equal to 30 meters per second times our time, which is 3 seconds. So our rx should be equal to 90 meters. So it is 90 meters, that is where it is going to move. So 90 meters forward like that. Let's look at our next problem. So provided that a projectile of mass 200 covers a maximum vertical distance of 10 meters, meaning that's the height, when it is launched at an angle of 30 degrees from the horizontal ground, how long will the projectile be in the air? It means to say we have a symmetrical type of a diagram when they say horizontal ground like that. So we are going to say, to find the height, so we are going to say to find the height, we can use our v squared should be equal to u squared plus our 2as, knowing fully that the final velocity is 0 should be equal to our u squared, which is everything y in the y direction. In the y direction, it will be our uy squared. Then we have plus our 2. Our a is equal to a negative 9.8 because it was going up. Then we have our height, which is our 10 like that. So we are going to have 0 should be equal to our uy squared. Then when we multiply this, we are going to get a negative of 196 like that. We take this value here, we are going to have a positive 196 should be equal to uy squared like that. We are going to find that the square root of this value is equivalent to the square root of 196 will give us a value of our 14. So the velocity in the y in that sense is equal to 14. If you want, you can just use the direct formula, which is your uy squared over your 2g. You can use this, cross multiply, then find what your uy is, but it's going to give you the same answer. So now if it is that type of a motion, if it is symmetrical range, remember the time taken shall be equal to, we are going to spell the word tag like that with a 2 in front. So the time taken shall be equal to should be equal to 2 by the 14 over our gravity is 9.8. So our time should be equal to, we have a 28 over 9.8, which is going to give us 28 divided by 9.8. This is going to give us a value of a 2.86 seconds. So you can use the direct one or the same one. S should be equal to ut plus our half a t squared, applying the y, because the y is the one that is equal to 0. Just as we have said, we can say 0 should be equal to 14t. Then we have the gravity will produce a negative, then half, we are going to have 9.8 t squared. If you want, you can do this, which will be t is common, open brackets, we have 14 minus half of 9.8, then we have a t like that. So this is going to give us t, then we have a 14, half by 9.8 will give us negative 4.9 t like that. So our t is equal to 0 at the point of projection, or 14 minus 4.9 should be equal to 0. Taking the 4.9 the other side, we are going to have 14 should be equal to 4.9 t. We divide the 4.9, we divide the 4.9. This is going to give us a t value of 14 divided by a 4.9. This is going to give us a value of a 2.86 seconds. So either you do that or you do this, you're still going to get the same answer. Okay, let's look at this question. So an arrow is shot with a velocity of 45 meters per second at an angle of 50 degrees with the horizontal. A person standing on the level ground 150 meters away from the launch point throws a ripe mango vertically upwards with a minimum initial speed necessary to meet the path of the arrow. Then we are told, at what speed does the mango leave the contestant assistant's hand? So, and also, at what time after the arrow launch should the mango be thrown so that it hits the arrow? So we have been told that it has been thrown with a minimum speed like that. So it has been thrown with a minimum speed. So since meaning to say it can only reach the height of the arrow, then starts to fall. That's the meaning. So let's look at the diagram. So this means that we are going to have something like this. So we have the arrow is thrown like that, then this person throws like that. So at that point it hits like that. So now one thing that we need to know about this problem is that let's first find the time it will take. Let us first find the time it will take for this arrow that was shot at this point to reach our range, which is equal to 150 meters. So what we are going to say is that we know that our range, first let's find our velocity in the y and the velocity in the x for the arrow. So we have our ux should be equal to v cos of our theta. We know that the velocity of projection, we have been given that it's 45. Then we have the cos of the angle is 50 degrees. So this is all for the arrow which was shot at this point. So this one should be equal to, we have a value that is equivalent to a 45 by the cos of 50 degrees. This will give us a value that is equivalent to our ux is found to be a 28.93 like that. Let's just find our uy in advance. So uy should be equal to v sine of theta. So our uy, so we have a 45 sine of our 50 degrees. This will give us a value that is equivalent to 50 sine of 45 sine of 50 will give us a 34.472. So this is our uy. So now the range is equal to 150. So we are going to say our ux should be equal to ux times time. So we are going to have our ux is equal to, we have found it to be 28.93 times time. The range is equal to 150. So we are going to divide 28.93 divide by 28.93 like that. So our t, which is our time, should be equal to, we have a 150 divided by 28.93. This is going to give us a value of 5.185 like that seconds. So this is the time it will take for the arrow to move from this point to this point like that. Now we need to know, so as you can see, at that point, when the arrow reaches that point, the two heights are the same in terms of y. So we need to know how much height did the arrow gain in that time. So to find out how much height the arrow gained in that time, we are going to say our s should be equal to u t plus our half a t squared. So to find height, we mean to say we are going to apply the y on all parts. So our uy, we don't, our sy is equal to, our uy is found to be 34.472. Then we have the gravity is negative, so it will be negative our half. Then we have our 9.8. Then we have our time. So let's correct things. We have by 5.185. Then we have minus half by our acceleration is 9.8 by our time, which is 5.185. Then we square this. So our height in the y should be equal to, we have a 34.47, we multiply by 5.185. This is going to give us a 178.73. We subtract minus half, this is negative, so minus, so we have half by 9.8, it is going to give us a 4.9. Then 5.185 squared, this will give us a value of a 26.884 like that. So multiplying, we are going to get a 178.73 minus, we have the 4.9 by 26.884. This is going to give us a 131.7316. So this is going to have 178.73 minus 131.7316. This is going to give us a value that is equivalent to 46.9984. So this is the distance above the ground the arrow will be at that point. So we have a 46.9984 like that. So it began, let's say it's moving from here, then when it reached this point, the height was a 46. Now this same 46 height will be the same height that the apple should be thrown up by the assistant. So it will be the same height because we want it to intercept the arrow. So to find the initial velocity, we are told to find the, let's move this. At what speed does the mango leave the assistant's hand? So the mango, not the apple, the mango. So now this person, the maximum height that they can throw the mango, since we are looking at minimum speed, minimum speed, it means to say when it reaches that height, or its velocity must be 0 so that it starts to come down. So what we are going to say is that, we are going to say using our v squared should be equal to u squared plus our 2as like that. We are going to find out, because already if it's the minimum speed to throw it, it means to say the final speed should be 0. So using this formula, we are going to say our v squared, now it will be in the y, should be equal to uy squared plus our 2as like that. So we are going to have our final velocity should be 0 squared if it's the minimum speed, should be equal to the initial velocity we don't know. So the initial velocity in the y direction for the mango, it's just going up, it's not even at an angle. So meaning to say, we are just going to say our uy squared, then we have plus our 2, our since it was thrown up, the gravity was acting downwards, therefore it will attract a negative sign. So we are going to have negative 9.8 times the height. It has to reach the one that we found, which was 46.99. So we are going to say 46.9984 like that. Then when we multiply, we are going to have our 2 by our 9.8 by our 46.9984, not forgetting the negative, is equal to, so we have our uy squared minus 921.1684. We take this value the other side, it will be so here we have 921.1684 should be equal to our uy to the power of 2. From here we find the square root of that value, which is going to give us the square root of our 921 is going to give us a 30.35 should be equal to the velocity that the assistant should throw it at to cover that distance. Now for the second part, which is saying at what time after the launch, after the arrow launch, should the mango be thrown so that it hits the arrow. So we need to know how much time it takes for the mango to reach that height of 46.9984. So we are going to say, using the formula of our v should be equal to u plus our at, since we know the final velocity at that time, it should be equal to a 0. If you want, you can use v squared is equal to u squared plus your 2as. And now here we don't have time, so s is equal to ut plus half at squared. You can use this if you want, but it's only complicating things because you will have to solve the quadratic equation. So therefore you are going to use this formula. So the final velocity at that point, at the height of 46.9984, should be 0, should be equal to, we have the initial, we have found it to be 30.35, then we have plus minus, since the gravity is opposing, 9.8 times t. So this value taken that side, it will be 30.35 like that, should be equal to, we have a negative, so even here negative 9.8 t like that. We divide 9.8, we divide negative 9.8. This is going to give us a t value that is equivalent to, when we divide this, we are getting a 3.097 or 30.35 divided by 9.8. This is giving us a 30.97 like that seconds. So this is the time it will take. So this is the time it will take to go up like that. But this arrow, it takes 5 seconds to reach that point. So this mango should be thrown, since it takes 3.097 seconds. It means to say this and this other one, the arrow, it takes 5.185 seconds. It means to say time to throw means to say we have to wait a bit for this mango to cover some seconds. So we are just going to subtract the time taken for the arrow to reach minus the time taken for the mango, so which is going to be the 5.185 seconds, 5 seconds minus the time of the mango, 3.097 seconds, which is going to give us a value of a 5.185 minus 3.097, which is going to give us a 2.088 seconds. So this is the time to throw. So that means to say he has to wait he has to wait a 2.088 seconds to throw the mango, so that when he throws, and the time it takes is equal to 3.1, when he throws, it will be able to add up and it will reach at the same time the arrow is shot. So that is how we go about that. After this video, you don't expect to have any challenges under projectile motion. Thank you very much for watching. Hope you would like, subscribe, and share for more. Comment if there is anything that you want. Don't forget to like so that my video can reach a broader audience. See you in the next tutorial.